All right, welcome everybody. This is the KubeVirt community meeting, December 9th, 2020. First topic on the agenda is the save and restore VMI proposal. So turn it over to Ryan Hollisey.
Hey, thanks, Stu. All right, I'm going to share my screen. All right, so a few changes since last time. I want to go over those changes, a few questions left from last time, talk about that. We don't need to go, I don't want to take up the whole time because I see there's another topic for David there. So if we get close to time, maybe like 25 minutes in or something, just flag me and we can make sure there's time for that as well. Okay, so I'll go over the doc. So I'm going to first just start with a few of the changes I made. So one of the comments from last time I saw, or I heard that was we were talking about that second use case, and I was reading it over and I was kind of thinking to myself, maybe this isn't quite what what I'm after. So I actually moved it down to a non-goal because I think the way I think this sounds is essentially like I described it as an export. So like exporting a virtual machine, taking something that's running and completely exporting it off a cluster, off of a completely outside of a cluster and saving it, and maybe putting it behind an endpoint and then downloading it somewhere else. And there's some examples of that, like OpenStack has some similarities there with like evacuate and migrate. This isn't exactly what I'm looking to do. I think it's sort of an extension on top of what I'm proposing, which is that we save the state of the running virtual machine and then we can export it. So sort of that API is something that I think is a non-goal, but something that could be added later on here. That was one of the changes. I added another section for save hook. I'm going to go into that in a second though, because I want to, before I even do that, I wanted to answer one of the, I think the most pressing question, I think from last time, I think it was Vladik asked it, was essentially what happens to the VRAM of a GPU device when we do this save operation. And so when I went back to my notes on this, the assumption that we can make, that I'm making, is that we don't have to worry about that will be there and that will be taken care of, that we will have the ability to hold on to the VRAM or the state of the GPU when we execute a save operation. And so for kind of my use case, the assumption is that would be there. And I think the assumption in general from the KubeVirt perspective would be that any device would be able to handle this if they want to be able to support save and work behind this API. Are there any questions on that before I kind of dive into some of the other stuff? Okay. Okay, so I think what to say first, device management. Okay, so one of the things I wanted to kind of focus on here at first, the question I wrote down for myself is, what would KubeVirt tell a device when, what would a KubeVirt tell a device, or when would KubeVirt tell a device to save? So like we have these, so I talked about here like hot plug devices. One of the things that is, my understanding is that when we want to do this save, we need to hot unplug devices. And as part of this is that this, the order of operations here is we'd pause, we'd execute this save, and we get the state of everything. One of the things I just kind of want to understand a little bit more is what would be the order of operations here? Do we need to, would hot unplugging essentially trigger a save in the device, or is a save an operation that is done by KubeVirt and then a hot unplug occurs? That's something I'm looking to investigate, but does anyone know the answer to that?
I'm not sure I understood your question fully. But do you mean that if KubeVirt should do the hot unplug or Kubernetes or what?
So one of the things, I think it was one of the comments on here, it's essentially that as part of the saving mechanism is that we would need to hot unplug the devices. I don't know where the comment is.
Okay. Or if Libert would do it, you mean?
Yeah.
Okay. I think it needs to be done, and Libert would just reject the save normally, I think. But yeah.
So you're saying if I do a hot on, if I do a save before I unplug, it would reject it? Is that right? That's what you said? I don't understand what you said.
I wouldn't 100% count on my words here, but that's my assumption. Yes.
Okay. All right. That's an action item for me then. I'll have to find that out, but that's one of the things here. So I want to understand a little bit more about this hot unplug piece because I know that was a comment, and that's basically everything I've read about this is that it's essentially functions like live migration, and that we need to do a hot unplug for the save, but I need to understand a little bit more about the order of operations. And that kind of leads me to the section, this section right here, which is like the device management in Kubernetes. And I was doing a little bit more investigation to this last week, and one of the things, like, just to kind of summarize what my understanding of like the Kubernetes device plugin and the way it works. There's an event that Kubernetes provides, or I guess sends out to device plugins, and they can listen on. And it's an allocate event, and essentially that is Kubernetes saying that this device is going to be allocated. And that's the only event that Kubernetes provides to devices. Everything else, including deallocate, is something that's up to the device entirely. And with save sort of like a different operation here, in that it is kind of like deallocate, but there's probably an intermediate step here where, okay, we want to save the state of a device. So this kind of, you can see how this kind of ties into like hot unplug, what the order operations are.
I think here you just have the same situation like when we do a normal VM shutdown. Like the QEMU process can already be stopped when we shut down, but the pod may still be alive for a few seconds, or depending on infra issues, maybe even longer. So if you stop the VM, at some point the pod goes to a final state where the devices are released and can be used somewhere else again.
Okay, but what about like, but I guess what about like telling the devices to save essentially?
So you would really want to tell this device to save its host state, or what?
Yeah, like, so essentially, like, kind of looking at this from the device perspective, is that the device has been plugged into the host, it's been allocated. It understands that it can understand when it needs to deallocate itself, because QEMU is terminating. It can it can hook into sort of that that process being removed. What about saving the state? Sort of like when the Virt launcher says, okay, we're going to execute a save and then exit. How would I, like, essentially I'm talking about like a way for the device to say, okay, we're doing a save, let's do something on the GPU to do a save.
I guess Vladik would be better here to answer. I'm not that clear.
I think the problem here is there may be a misunderstanding what the allocate event does. I'm racking my brain because it's been a while since I've looked at this, but I think that the allocate event is to tell the device plugin that a physical device exists. It is not making an assertion about whether or not it's used by a pod or not. I may be wrong because it's been a while since I've studied this, but I think that's why you only have an allocate, is because it doesn't make, like, we're not hot plugging at the physical level these devices.
Yeah, well, allocate just moves this device into a pod. And then when you terminate the pod, the device will get deallocated. I'm not entirely sure what do you mean, Ryan, by saving a device state. What exactly?
Sure. So
yeah, especially if you unplug it. So if you unplug it, you basically destroy the state voluntarily and say, yeah, later on you may plug it somewhere again, but there is no state left on the device in that sense, right?
Yeah, that's what kind of my question is here, is like, if if I hot unplug the device, right? The state's gone. So what I'm trying to say is like, I should save before I hot unplug, right? I should send an event to the device, say, hey, save the state somehow, save it to disk, whatever it is, so that we can hold on to it for later and not just like do a hot unplug and just wipe out everything.
I don't know. Does NVIDIA drivers provide such hooks or any drivers? I'm not aware of anything like this.
Okay, so then if we do a hot unplug, then the entire state of the device is gone. Let's go back to that. Is that right?
I think what you're wanting to do is just pause, and then if NVIDIA has some sort of hook to save the state of your GPU device or whatever, execute that at that point for detaching. Is that not accurate?
Yeah, that's what I'm talking about.
Okay, so I don't think I'm kind of confused at why we're getting at the device plugin level. So that's the equivalent of somebody, if you think of the container environment as a machine, it's the equivalent of somebody plugging in a GPU or unplugging a GPU from that host environment, which isn't really necessarily related directly to what you're trying to do within that pod environment. So you have a guest, you need to pause the guest, and then you need to save the state of that GPU. But whether it is getting deallocated from that pod or not, that's like a different level.
So what I'm saying, yeah. So I understand. Okay, I think I understand some of what you're saying. So the reason I'm mentioning it is because there would need to be some tie-in. Like in other words, we can't, like if I do so I do a pause and execute a save. What's going to sort of execute those, like say that event, or what's going to cause like for example, the GPU to suddenly want to do the save? That, like, what's going to call that? Like that's kind of what I'm getting at. Is that I think there would need to be something, right?
Yeah, that would be you at some point. Yeah.
There is nothing, as far as I know, in the Virt environment to just do that for you. It's either something your device can do, or the VM guest can do due to something special. But there exists nothing to just use.
But so the device plugin needs to do this. I think it's like where we are, right? The device plugin needs to do this, and that I understand that. Now the device plugin is going to, how is it going to know we're saving?
I don't think the device plugin is even capable of doing anything like this. I mean, it doesn't. The only thing that the device plugin does, it moves the device from or within the pod. It doesn't do anything else. It has to be something else, or maybe some kind of a driver, guest driver, that recognizes that it's being unplugged, so it will send the save command. I don't know. It seems like a more driver thing to me.
Okay. All right. Maybe it's not a concern then. Okay. Then let me just take that as something that needs some more investigation then. Okay. All right. Next, the next topic. I wanted to go back to the API again. So kind of where we left off last time. I'll try and summarize. We talked about the virtual machine snapshot as a way of a point in time of a virtual machine. And one of the kind of what I think we talked about last time is that the virtual machine instance, if we were to do a save, one possible way to do this and to have it end up in a snapshot would be that we create a virtual machine and then we would take that snapshot. My question, let's see that I wrote down. Okay, if you have, let's say you do a snapshot of a virtual machine that has a virtual machine instance, like what ends up being the result? Like what would be the difference? How does that API function? I don't know, that might be for you, Michael, if Michael Hutchinson is here.
So I didn't think that I think they would look very similar to the offline snapshot. But maybe we do have to save the VMI YAML as well. I don't know.
Okay. Okay. Yeah. I mean, I guess that.
I mean, yeah.
Yeah. Sorry.
There
go
wouldn't
ahead,
be there wouldn't be so much difference from the perspective. You would have the VM. So you would save the PVCs. You would have to snapshot them, right? You would have to create a new PVC where you can save the memory state, and then you can save a VM or VMI spec, and then on restore you have to reverse it basically. I mean, that's slightly different than an offline. From the artifacts, it's almost the same like an offline snapshot from a VM. It's more like the save and restore are involve more steps. Right, Michael?
Yeah, exactly. Yeah, the only thing is the memory stuff I forgot about, but yeah.
Okay, so then if you were a snapshot a virtual machine that has a VMI, disk, memory, everything. Okay, so that's something we would expect to happen. Okay, does that I mean, to me, that I think it makes sense then to go that route. I mean, because I know like Michael, in case you want to comment on it last time, because we didn't really go into too much, but like I know that the virtual machine snapshot can support kinds of virtual machine instances. I don't know if we want to open that can of worms again, but like what do you think like in terms of this route of going from virtual machine instance to virtual machine to snapshot as opposed to essentially having the VMI as a supported kind in the snapshot?
Sorry. So do you mean like what would happen if we had a VM running with a VMI and then someone did a VMI snapshot versus someone doing a VM snapshot? How would that be different? Or
I would mean like if someone had a VMI, they did not have a VM, and they were to do a snapshot.
Yep.
Is that what you just said? I might just repeat.
Yeah, I think that is something that we would like to support. It would just be the kind would be virtual machine instance instead of virtual machine.
Okay, so I don't know what. Yeah.
Isn't this like a VMI? It's like an anonymous VM, and the VM is a specific one that you define. So where do you assign these snapshots to what?
So it doesn't matter. I mean, if there is a VM spec or VMI spec, at the end you just define a configuration of a running VM. I mean, on the VM you can say it should not run, but at the end you have all the information there.
Yeah, but then when the VMI dies, then it will take out all the snapshot, everything. You have nothing.
Why?
Why?
Because the VMI, when you kill the VMI, then there is nothing left. When you stop a VM.
Yeah, sure. You have to do it while. Yeah, that's why you have to pause the domain. You're not. I mean, you can't destroy the VM and then try to do a live snapshot from it. I guess that's clear.
Yeah. So if you have a VM, then even if you stop it and even if it stops or for any reason, you have no problem to restore something. But if you have a VMI that runs, you must have it running, stopped, paused. But if it stops, then you lost everything. So, and that's an important point if someone wants to keep something.
Yes, I mean it's a live snapshot. Yeah. So you have to, yeah. But even with offline snapshots, you have to snapshot every PVC and every disk. And the main difference is that you do that while it's running. Yeah. But maybe I didn't get what you mean.
So I think what is going to be important is that we, don't, as long as we have a copy of the VMI spec, if the VMI is not running, we can still get all the PVCs and everything that was attached to it and snapshot or.
Yeah. I think it's fair to just extend what we have right now. it's just on a live instance, of course. So you're doing the, and yeah, I guess.
So
Yeah.
so how could we, so what would be like a fair statement here? Would you be allowed to do a virtual machine snapshot using that API, doing the virtual machine snapshot on a running VMI with no VM? Would the answer be yes or no?
I think we're jumping ahead. I mean, I don't know what that would look like right now. I think we definitely want to support that, and that's a good possibility, but we're jumping past the just get online virtual machine snapshots working and then discuss the step of how to support VMIs directly. Like, we're skipping steps as far as we haven't even gotten the first thing sorted with online virtual machine snapshot looks like. We're jumping directly to the VMI.
Well, I want to clarify one thing. So by online virtual machine, so that would be a virtual machine with a virtual machine instance. Is that right?
So,
with
say that
the
again.
intention of a virtual machine instance.
With the intention.
The run policy does not indicate that you were successful to actually run them.
Okay, so that means you have a virtual machine object, and do you have, I'll just say you have to have a virtual machine. Well, like, I don't know if you do have to have a virtual machine, but the intention, we'll just go with that. So there will be a virtual machine instance object. So that's what you're saying, Dave, is that that would be considered online. What do we call it? Online snapshot?
Sure. So what I'm saying is today what we have is we have the ability to take a snapshot of an offline virtual machine. The next step in this chain seems to be, all right, so now how do we take a snapshot of the virtual machine while it's running? And then if we can work out that end to end, then it's pretty easy to take that same technology and the same workflows and everything and say, well, how does this apply directly to a VMI now? Like, I'm just worried from a usability standpoint that we're jumping steps that makes the conversation difficult. Is that, maybe I'm alone here, I'm not sure. I feel like we're making it more difficult on ourselves trying to jump directly to the VMI without thinking from a usability perspective, how do we segue into what we already have today into the next logical step of that?
Yeah, I agree. I think the jump from online VM to VMI snapshot is small.
So we think about it within that context. It's really easy to get what you want, Ryan, and the next step. Like it's just difficult for us to make that jump right now, I think.
That's fine. I think, yeah, I just want to make sure that we're in alignment. That I think, okay, so the way I understand this is like, to go about this right now, offline virtual machine snapshot, which is what's implemented, which is just a virtual machine without the intention of a running virtual machine instance. Online snapshot, the next step, what you're saying is a virtual machine instance with the intention of a VMI and doing a snapshot of that. And then the follow-up step, which is kind of some of what I've talked about, which is like, I guess call it online virtual machine instance snapshot, which is not having a virtual machine object, having a virtual machine instance object and being able to snapshot that.
Right, and at that step, all the technology already exists to do that. It's just a matter of defining the APIs to do it. Like,
okay.
Yeah, and in principle, if you do it for a VM and you have it for a VM, then it's in principle. I'm not saying this is the formula. It's as simple as, in theory, you could just wrap any VMI in a VM spec and immediately use it with minimal code changes. Then so similar it would be.
Okay, that's really helpful. Okay, I think that really clarifies it for me really well. Okay.
I'd like to play devil's advocate and point out that there is no such concept as migrating a virtual machine instance. And that has to do with the fact that a virtual machine instance is either present and running or it doesn't exist. And so there's no same way that we track. And that's why the API itself does not support even attempting to migrate a VMI. We do it at the VM level.
Nope, we migrate VMIs. Sorry.
VMIs.
Yeah,
only VMIs.
Okay. So it's only at the running level that we care about live migration.
We definitely have here kind of a little bit of attention because, I mean, all features which we normally have first are on the VMI level. and then we just have extensions on top. But the snapshots actually went a different route. So with snapshots, since we made offline snapshots first, and you can't snapshot non-running VMIs because they don't exist, we have now end-to-end offline snapshot flows for VMs. So this is kind of the difference compared to the usual flows where we start implementing things. But I think we can easily extend it for VMs with online snapshots, and then you get, as David said, you get all the knowledge and all the missing bits for then afterwards make it fast available for VMIs too. Does it make sense?
Yeah, it makes sense to me. Yeah, I think that's for me. Yeah, I think I wrote down those 3 things. I'm going to spell them out here in the doc because I think that really clarifies exactly like the
and then it should be really easy for you, at least for the VM case, although that may not be exactly what you want, but then it's really just
that's fine. I think
extending the given steps with, okay, pause the VMI, do the memory snapshot, then do the usual PVC cloning, which happens with downstream instances. So it would really pretty naturally fit in what we already have.
Yeah, that
would implement all the technical necessities for the rest too.
Okay, yeah, that makes sense to me. Okay, okay, so only one other thing. So does this this API direction, so going right to online snapshot, that's kind of the first step. Is there any do we think, is there any other routes we could take? Like, I kind of glommed onto the idea of doing this offline, or doing the virtual machine snapshot. I think it seemed to fit, but is there like any other ideas? Like, do we have, like, does anyone think like we should go a different route, like different API? Like, I don't know, like, is there anything else? Like, anyone have any different opinions about that? Like, or just folks agree this is a good path to at least start on?
I think it's the logical next step. I think that's kind of what the planning has been. Start with offline snapshots of virtual machines, because that's obviously the easiest thing and lets us focus on the API and just get the mechanics of the usability done. Like, this is how you use the API. This is how you restore things, stuff like that. And then the next step being saving it while it's running.
Okay.
And I just will say, Ryan, I don't know if you're aware of it, but there is going to be in kind of orthogonal path that we're going on with Valero, which is more of a disaster recovery, like Kubernetes disaster recovery thing, where we'll be backing up VMs, but it's kind of different, but sort of related.
Okay.
So if, that Valero stuff is supposed to be coming along for our next major release.
Okay, cool. Yeah, well, I'll keep an eye out for on the channel and for anything you guys post on the mailing list. All right, cool. I have one more item, but I know like I'm taking up most of the time here, so I did want to talk about storing RAM and PVCs, but David, I know you have another topic here. Do you want to? I don't know how much time you need, but do you want to take it away, and I can do the last topic. Maybe I can carry over to next time.
Sure, that might be wise, because I know we have some people on the call just for this next topic, or at least I think we do. All right, so let me pull up the doc real quick. We're kind of in a mess. we wanted to, I'll explain what's happened first. So we consume a container that has libvirt and QEMU in it, and that's what our virt launcher container is derived from. That's like the base container for it. That libvirt and QEMU container, the version of libvirt and QEMU in there comes from a special built repo that's kind of derived from what RHEL is doing. that's difficult for us to maintain right now because we're having to depend on some custom builds to occur there, kind of one-off things to get features into it and everything. And ideally, we would like to switch to something that is supported like like a Fedora stream or something like that, that's getting the latest and greatest all the time and lets us kind of adopt new features quickly so we have a higher velocity for development. Now, the issue here is we made that change. It breaks compatibility with the previous packages that we were consuming because there's a machine type difference between these two packages. So it means that a VMI that's launched with our old runtime, so in a previous KubeVirt version, can't migrate once we've updated to this new runtime. So it breaks migrations, which is, it's not a great thing. The risk here is we have to make a decision if we want to continue with this new Fedora package as our base container or not. And if when we commit to this, if we ever want to change it, we're going to break migrations yet again. So it's kind of like a situation where we have to be really sure that if we're going to do this, that it's the right long-term play for us, or we run the risk of further disruption soon if we have to make the switch again. So I don't know how I feel about this right now. I would like to stay on something that's stable. So I like the fact that we were consuming bits that were kind of the latest and greatest in RHEL. But at the same time, I want the freedom to have the development velocity that we need to introduce new features quickly without being tied to the RHEL release cycle. So I don't know, where do we stand here? Is there an intermediate? I know that the Centaur stream stuff was announced. Well, it's been announced for a while, but that's kind of the future here. Is there a way we could leverage the Centaur stream to somehow free us from the RHEL release cycles and get like early builds quickly that we can consume in KubeVirt, yet still kind of remain on something that's stable and compatible? Anyway, I've thrown, that's kind of the state we're at right now. What are the thoughts? Can somebody else jump in here?
We're all just kind of sitting here thinking about it. I thought the Centaur stream, maybe it's not clear to me what the difference is. I know that we're not targeting a specific version number anymore, but that just means to me it's a rolling release of whatever latest is. But it's still, CentOS always follows RHEL. It's always behind it because of, by nature of how it's built, right?
See, that's the thing I don't understand. Maybe somebody do we have anybody who's building these packages?
Can you hear me?
Yeah, we can.
All right. Okay, so I will jump in since I'm the person who unwittingly caused all this trouble. So I was responsible for switching the container image to use Fedora content instead of RHEL content. And so to give you some background on this, for the people who are not aware of it, basically the situation up until very recently was that we were taking the RHEL RPMs or the source code rather, and modifying it so that it would be possible to rebuild it in the context of Fedora, because the image that has QEMU and libvirt in it is based on Fedora and always has been. So we were basically taking the downstream spec files and sources from RHEL, then performing some surgery on it so that it could be built in the context of Fedora. And the result was something that was very close to what RHEL has, but it was not, technically speaking, the very same content. And this sort of surgery was time-consuming and not really scalable. It was getting in the way of, for example, backporting changes, because every time a new RHEL package would come out, we would have to perform the surgery again, right? And so the decision was made to switch to Fedora because to Fedora packages, because first of all, that does not require that kind of surgery. We can just take the the spec file exactly as it is for Fedora, from Fedora, and just rebuild it on Fedora. It's the same thing, and it doesn't require any changes. That makes it easier to pick up a new upstream version, to pick up a new downstream version. So if there are changes in Fedora, fixes that are backported, which also happens, right? Because we don't necessarily update libvirt or QEMU to the very latest versions all the time. We have imagine that we release a version of CMV that has a certain version of QEMU and libvirt, and then we find a bug in those versions, and we need to backport a targeted fix. We will not just rebase libvirt and QEMU. We'll just pick the fix, right? And that becomes trivial when we have these Fedora packages. And the other thing that we are starting to do, and some work has been put into this already, but it's not been fully formed yet. But the idea was to start and consuming newer Fedora packages as they are produced, basically, as new libvirt and QEMU releases are introduced into Fedora, and possibly even from Git content, and just feed those into the KubeVirt CI, and just be able to detect well in advance if some changes in QEMU and libvirt will require changes in KubeVirt or will cause trouble for KubeVirt. This is sort of the background. The problem with this is that the machine types are different, and we did not think of that. So yeah, personally, my opinion is that the previous way that we were doing things was not really, did not really scale, and was getting in the way of velocity in development. And the new way of doing things is much better on that regard. But there is the question of, yes, this breaks migration to the new version. And I'm not involved in the KubeVirt community enough to know whether this is something that is entirely unacceptable, can be acceptable in extreme conditions. You tell me.
If we can pause on that question for a moment, and well, no, let's answer that. But the question I would like to answer after that is, if we do decide to adopt this painful process, is Fedora the right target? And what I mean by that is, how big is the Fedora container that we're then basing on? Could we be borrowing trouble for ourselves and wanting to switch again? Let's make sure that we do that change only once, if possible. But
right.
To circle back to you, go on.
No, I'll go ahead and answer your question. So the thing about Fedora is that, unlike RHEL, is sticking very close to upstream sources. In fact, if you go and look at the spec file for libvirt in Fedora, they just take the upstream spec file, which is in the libvirt repo, and basically just reuse that one. So when you get a Fedora build of libvirt, it's pretty much upstream. So that gives you the ability to, you cannot get much closer than to upstream than that, right? Whereas in downstream, there can be changes. For example, the machine types that we were using before and that we don't have in the new packages. That's because that's something that RHEL introduces downstream. It's something that does not exist upstream at all. So the Fedora builds and the upstream source code are much more close to one another and compatible to compared to what the RHEL builds were. So imagine that in the future you want to switch the container image to something like I don't know, Alpine Linux. That would be much smoother, I imagine, than not switching from RHEL to Alpine. Basically, the RHEL to close to upstream is the painful switch that we're discussing now. And once you are closer to upstream, then you should be able to switch to something else which is also close to upstream relatively easily.
Well, I want to understand the CentOS stream stuff before we get too far. does this help us increase velocity? Because it gives us the chance to have what would essentially be a preview of what's going to be released in RHEL, possibly on a timeline that we define rather than being something that's completely tied to a RHEL release. So we know this. We know that Red Hat has a downstream product that's consuming KubeVirt. And whenever KubeVirt is being pulled downstream, that the version of libvirt and QEMU has to support everything that the upstream, or at least has to be compatible with everything. So we already have that, where if there's something that makes it into upstream, eventually it has to be ported downstream. So that's going to occur. Is there a way that we can use the Centaur stream to release things quickly that it allows us to increase our velocity upstream while consuming something that is stable and actually kind of similar to what is in this Red Hat product?
I guess the question to me is it difficult to build the upstream libvirt sources on downstream? Because CentOS is much closer to downstream than Fedora is, if that makes sense. So, yeah, because I think that to take a step back, the main motive of what we're trying to do here is to alleviate the pain point of a custom build process where we started from downstream. If it's easy to build upstream on downstream, then the question of CentOS versus Fedora, I do think becomes a valid one.
Well, so the CentOS stream, my understanding is it's just taking the latest like development work from RHEL, was happening in RHEL, and it's just giving a preview of that. So it's their internal release process that is, sometimes they're rebasing off upstream, and sometimes they're porting fixes and things like that. It's different though. I don't think that we wouldn't be as close to the upstream as we would be in Fedora necessarily. Right. So this is a question for the libvirt or the people building these packages. Can we utilize the CentOS stream to gain a higher velocity than we are today with this unsustainable system of one-off builds for Fedora?
So the problem is not really building upstream source code on either Fedora or CentOS stream or CentOS 8. You can build it just fine. But if you build the upstream QEMU, whether you build it on Fedora or CentOS or RHEL, you're still going to get the same set of machine types. And that does not include the downstream specific machine types that are introduced by the downstream packaging in RHEL.
Exactly. So is there a step that we can take to consume the downstream ones?
Another question, so that we had them available, right? So this was kind of a mistake then, or that we even had them available?
Sorry, Roman?
I'm surprised now. This means that these machine types are also not available in CentOS, for instance?
I think, no, that they must be available because CentOS
is a rebuild, right?
Just rebuilding the content.
Yeah. And we had them too, right? So this is by accident more than.
Yeah, well, basically, what we were doing before is that we were taking the RHEL content and using and rebuilding it, right? But if you rebuild it, the source code is the same. So yeah. All the patches that are introduced downstream are there, but that means also the changes, including the new machine types, different machine types that are not matching what upstream produces.
Okay. So this surgery that you talk about, it wouldn't have to occur in the CentOS stream. Is that accurate? You'd just be able to pull it straight over and build it for the CentOS stream.
No, I think what's afoot here is we keep avoiding the real question of how painful is it if because if we switch to the upstream sources from the downstream sources is basically the question we need to be answering. And it doesn't matter what base OS we're on. because you're still going to have to do that surgery. If we start from the downstream sources, we still have to fiddle with it before we can run it.
No, I'm not sure. That's what I'm asking. Do we have to have that surgery for the Centaur stream? Or is it just pulling directly the preview of the downstream into a community repo?
Yeah, I'm not 100% familiar with Centaur stream, so I'm hoping that I'm not going to say something which is not accurate. But based on what I know about Centaur stream, my understanding is that it is basically a snapshot of the development status of the next RHEL release. And as such, I expect it to contain all of the downstream patches that will eventually make their way to RHEL. And so I expect them to have the downstream machine types instead of the upstream ones.
Right.
So if you started using Centaur stream content, you would probably not have to deal with the difference in machine types.
So let's talk about the merging of features and backporting and everything. That no longer becomes cumbersome with Centaur streams, does it? Because Rail's already going to have to do this process in order to support their product. So they already have to have a stable version that supports the features that KubeVirt needs. So that's already going to be part of their process. And the thing that increases velocity with the stream is that rather than waiting on Rail to release, make an official release, we can get this preview immediately. So right as the work is done, we can consume it down or in KubeVirt. Is that accurate? I'm just trying to see if this is a happy medium for us.
Right. It sounds about right in theory. I don't actually know whether there are any delays between when, like, I don't understand well enough the Centaur stream development model to be able to tell you that changes are merged, how long it takes, right? If we find an issue and it gets fixed by RHEL engineers, how long does it take for that to show up in Centaur stream? I have no idea. Right now, with the new process that we've put into place, we can get that. The person working on these special builds is the same person who maintains KubeVirt in Fedora, so they can do that very easily and quickly. I don't know whether that would change if we consume Centaur stream. But the other thing that I think is important to keep in mind is that Centaur stream content would still be more different from the upstream sources than Fedora content is. So this idea that we have been exploring of being able to just take content of perhaps the development status of KubeVirt and QEMU and build a testing container out of that and be able to catch potential mistakes before releases of KubeVirt and KubeVirt and QEMU are out, that now suffers the same issues that we're discussing now.
I think so, though it's fine and it would still valuable to do that, because we can still run the test. We would still see, when we then suddenly arrive at KubeVirt or QEMU X, we will run into this problem and can early react to it. Yeah. I'm not sure if that would really contradict with the idea of having a very stable and tested base for our tests and for the users in KubeVirt. What do you think?
I think that they're orthogonal. Like we can consume something stable while still have this testing on something that's the super bleeding edge development.
I would also say I would not like the idea of having maybe two launcher versions, one using Fedora and one using, for instance, Centaur stream. The main issue it would allow us to see, it would allow us to develop new features then, which would not be there yet in Centaur stream and so on. May make things a little bit difficult. But.
It's difficult to explain, and I think that the test matrix.
You wouldn't be able to migrate between those, though.
Yeah, but that would be fine because people could then choose they wanna have KubeVirt 0.36, or maybe at some points KubeVirt 1.1 or whatever.
So,
And and I choose delivered QEMO from Centaur's 8 stream, and then they would have to stick with it in that installation. And for other installations, they would have to stick with the other one, and they may then support different features.
So
it's complicated.
what would be
now
the
it
difference
is.
in KubeVirt CI then?
That's
Yeah,
the thing. Yeah, it splits the matrix. We have a giant test matrix now.
Yeah. That's a disadvantage because you would have to test some you would have to ensure that some features are not triggered on one version and only tested on the other one, and you would need to have all of them on the PRs.
My problem with
Go ahead.
CentOS, I'm sorry. I was just saying that my problem with the CentOS stream is that we've seen that previously we had issues. I mean, so we consume CentOS stream and KubeVirt CI, and we've seen that when we had issues with the kernel compatibility and some bugs that we've seen that with the nested virt previously, it wasn't so easy to fix them and get the new packages delivered. So I don't know.
So you already have
explain that.
with getting new fixes and contents into Centaur stream. Is that what we're trying to say?
You mean that the packages weren't updated regularly or with any sort of expected cadence? Okay.
So the way we consume it is that there's some kind of an image that we pull down and then we use that, and it's not always stream. I mean, we don't get it on time. There was some kind of a version out there that, I don't know, it was outdated by itself.
Was it more? So was it no more an issue of us not updating the base image regularly, or was it an issue of not being delivered?
A newer version wasn't even available.
Okay.
I don't know. Honestly, as I said several times now, but I'm going to repeat it. I'm not that familiar with the Centaur stream development model. I've not investigated that in detail, and I guess that's something that we might need to do. Like if Centaur stream is basically the development stages of the next Rail release, right? I expect changes to be merged into it to be subject to at least some of the same process that Rail changes have. And I don't necessarily see that as being as lightweight as something that you can get in Fedora. If you want to get a change in Fedora, you can get that in pretty quickly. And CentOS stream, I'm not so sure.
Here's my thought. There's enough uncertainty here that I'm hesitant to commit to anything quite yet. I'd like to investigate the CentOS stream a little bit more and investigate there's options that allow us to increase velocity while remaining on something that's closer to this stable Rail version of libvirt and QEMU that benefits us from a few standpoints, I think. What we're in is this kind of unfortunate situation where we're trying to make an upstream release and we have, like, there's pressure to make a decision, and I'd like for that pressure to be relieved. So is there an option where we can get, I know this is painful and it's not fun at all. Is there an option where we can get a one-off Rail AV build again that has what we need to unblock us upstream in KubeVirt? It frees us to have this, just give us a little bit more time to have this discussion to make sure that we're making the right decision for upstream KubeVirt. Because the situation I don't want to be in is that we jump to this Fedora package and then we find out soon that the right decision would have been to jump to the CentOS stream, and then we have another kind of invasive, disruptive break in our compatibility.
I think this is right now really tough to find out what's the right thing. We should have a follow-up talk soon, I guess, meeting.
So can we unblock ourselves? Is there anything can we get one of those unfortunate rail builds?
So you're talking about basically helping us now over this one release, and then
get us
having
out of
one
this
more
release
month to have more time. Is this
sure
time frame?
Well, realistically, just given what month we're at, it's probably going to be January that we make this decision, just because of the holidays and everything. But I'm just trying to buy us some time, because if we're not going to make a release if we can't. We're going to be indefinitely blocked on this. We probably won't have a January release either if we can't come to an agreement on this.
Yeah, so sorry, so can I understand a bit better? So there was, because we made the switch to Fedora content, what feels like a lifetime ago, but time doesn't have any meaning anyway. Was no upstream release of KubeVirt made with the Fedora content yet?
No, there was no release yet. It would have happened today, right?
Well, actually yesterday.
Or yesterday.
Yeah. So we found that, it's been almost exactly a month. And I know that work started probably longer than a month ago. The problem is when it actually gets merged into the code base, that occurred after the most recent release. So yeah, we don't have.
Yeah. So it was on master for 2 or 3 weeks. Then our automation cut the release branch, and the release where we have a few more days until it's really doing a release. And there is where David caught the issue with the machine times, because
it's not just the machine. Yeah. We broke it in a few.
There is more.
ways.
Yeah. But you added more upstate tests regarding to migrations, and there you discovered the issues.
Hey, David Roman, this is Chris Caligari. I'm just a layman here, so can I just make a quick comment in that we are pre 1.0, and so can we expect this change to be implemented before a 1.0 release?
Yeah, absolutely. So most certainly we want to have a solid direction on this whole discussion before we go to version 1. That's why we even have the option. The reason I feel like we could even get away with talking about switching right now is because we're not version 1. It would be a much more difficult decision if we had just advertised that we're stable and version 1, not going to break compatibility. The fact that we're not there yet,
We definitely don't want to become like Puppet Labs and changing their entire engine every major release.
I guess we could right now still argue that that migration is behind the feature gates. So, but
no, but like let's take advantage of this flexibility if we need it. But ultimately, I agree that if we may not have all the full picture, and we still have time, I guess, to like give it more time to think it through and make sure that we make the right decision now with more data, with more information available to us. So I guess, so I'm not the person making the downstream, the weird surgery up QEMU and liver builds. That would be cool. And I think we can ask him to make one last build, even though it must have been the 5th time now that we asked him for one last build. So, but I think he will not say no, and we can try and do that. But of course, this is now basically on the critical path for the release, right? It's already being delayed because of this, and we need to get this sorted out yesterday, basically, right?
I don't want it to. Well, it's important, but we can delay the build for a little bit. We need it out this month, preferably before, like by next week.
Let's not mince words. I just want to understand very clearly how this is already delaying the release, and we don't want to delay it any further than necessary, right?
Yeah, it's delaying the release, but really a few days. If we know that we would get such a build and this would unblock the situation, a few days delay is not so much an issue.
One thing to keep in mind is that even if we'll build a real AV right now with the current content, it means that we will break Virt IFS. So we'll need to do more surgery.
Yeah, and we also had the issue with the hot plug on volumes, right?
So we just need to coordinate these two things with Cole. I think that's the solution. It's unfortunate. Let's coordinate things that we know with Cole, get the build we need, and we'll have to sort this out in January.
Yeah. The thing that I'm mostly concerned about is that we have done some backports to the Fedora builds, specifically for issues such as the Virt IFS that Vladek was talking about. And I'm not exactly sure where we stand when it comes to rel builds for those. So we have to be careful not to find ourselves in the situation where we accidentally reintroduce a bug that we have already fixed in the Fedora builds. So we have to be careful there. But I'll talk to Cole, and I think he will agree to make a build, and I think we can do that relatively quickly. But it will take, if my experience is any my previous experience is any information, it will take a few days for it to get through CI anyway.
Yeah, that's my expectation. But yeah, a few days is okay. Because otherwise we're just talking about permanently. We are talking just about a much longer period.
All right, so I'll talk to Cole and try to get the ball rolling as soon as possible. I mean, we can, yeah.
Yeah, let's stay in contact. We're anyway on Slack and so on. We can just stay in contact and coordinate this.
Okay, apologies everybody. I would have cut that decision off because we're 5 minutes over time, but it was really important to let that conversation conclude. But since we're out of time, we probably don't have room for any more topics. So with that, I think we'll just close. And thank you, everybody. See you next week.
Thank you too. Bye.
Thank you, everyone. Bye-bye.